Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's ContainerJournal.com program, brought to you by Techstrong, AWS, and Snyk. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting program ahead. First, I do need to cover just a couple of housekeeping notes. Today's session is being recorded, so if you miss any of our discussion, maybe you'd like to rewatch or share with a friend. The on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, we want you to send those in to us using the Q&A tab. You can find that Q&A tab on the right side of the screen with a few other interactive options. The first one that you'll see is the chat tab, and I'd like you to start warming that up for me right now. Let us know where you're tuning in, and I just want to make sure that chat button's working. And of course, before we close out, we are giving away 4 $25 Amazon gift cards, so be sure to stick around. So our topic of discussion today is live hacking container workloads on AWS. And I'm joined by David Schott, lead partner solutions architect at Snyk. And we'll also be joined by Marco Morales during our Q&A portion here at the end. So David, it is my pleasure to kick the floor over to you. So why don't you go ahead and get us started.
All right, thanks for the intro, and hi everybody, how you doing? Welcome to the webinar, Exploiting Vulnerabilities in Your Container Workloads on AWS. My name is David Schott, and I'm a partner solutions architect at Snyk, based out of Brooklyn, New York. Today I'm going to talk to you about first, what is Snyk and what is the problem that we solve? And then we're going to see some real hacks and really see what it looks like to hack into an application from a malicious person's point of view. And then I'll show you how to find and fix security issues using Snyk, and then we'll wrap up and do some Q&A. So if you have any questions, feel free to ask along the way, and we'll try to get to you at the end. So first, what is Snyk? Snyk is a developer security platform that helps you find and fix issues in your first-party code, your open source dependencies, your container images, and your infrastructure as code. We were founded in 2015, and we've been growing rapidly ever since. And in the beginning, we knew that there was a shortage of security experts out there. It's actually about 8-to-1 developers to security experts. And those security teams don't want to be a bottleneck. So with Snyk, we enable the security teams to help developers find and fix security issues on their own as part of their regular development process. And in case you didn't know, Snyk stands for So Now You Know. Now, if you've been in the industry for a while, you've witnessed firsthand what's on this slide. About 5 or 10 years ago, we'll call that the pre-cloud era, developers were only responsible for their application code and a few open source dependencies. And back then we followed the waterfall methodology, not agile. So we'd say things like we're throwing our code over the wall, and that's when operations teams would create virtual machines and networking infrastructure over in the colo somewhere. And that process could take weeks or even months. But nowadays, developers are using cloud, containers, and Kubernetes, and they're moving faster than they ever have before. But because of this, there's an increased responsibility for these different areas, and developers aren't experts at everything, so security vulnerabilities definitely creep in. Now, if we dissect a modern application, it's very much like an iceberg. At the tip of that iceberg, we have our first-party or proprietary code, which is a small part of the overall code base, but it's frequently touched and deployed daily in some cases. So this means we need to scan for security issues quickly and highlight those issues before developers move on and change contexts. But ultimately, what we tend to do in this layer is glue together the open source dependencies in the layer below. Now, our open source dependencies are often the largest part of our code base, and there's a complex supply chain there. It's important to understand where these are coming from. And remember that one line of code for a developer is actually a huge chunk of code in the app. When you add a dependency, you're actually copy pasting all of the code in that dependency into your project. And also, dependencies have dependencies. These are called your indirect or transitive dependencies, and this is where we find the most vulnerabilities. Then we take our application code and our dependencies and we package that up into a container image, and we rely on official images from places like Docker Hub and so on. But official doesn't always mean secure, and often we find significant vulnerabilities in the base image or vulnerabilities that get added by user instructions while building that image. Then lastly, we have our infrastructure as code, which of course is what we use to run our services using languages like CloudFormation, Terraform, Kubernetes manifests, and Helm charts. And I think it's straightforward for developers to get something running, but not easy to make it run securely. And this is one of the reasons why the number one cloud vulnerability is misconfiguration in your cloud environment. So as I said earlier, Snyk helps find and fix issues in the areas that developers are working. So it's not just integrated in one place like a traditional tool. Instead, developers see security issues in their IDE, in their pull requests, in their source code repository and the branches in that repository. They see security issues in their CI/CD pipeline, and this is where the security teams can set up a gate to prevent vulnerable code from being deployed using policies and thresholds. Then towards the runtime, we integrate with your container registry, your Kubernetes environment, and your serverless functions, and this helps to protect applications after they've been deployed. Now I'm going to show you many of these in the demo that I prepared for you. So now the fun part. Let's do some real hacking. And the point of this is to help you understand what directory traversal and arbitrary code execution really means when you see those names. And then we're going to use Snyk to find and fix the vulnerabilities that we're exploiting. And while doing that, I hope you'll see how easy it is to find and fix security issues using Snyk. So to set the stage, many of you might remember the Equifax breach, and this was caused by vulnerability in the very popular Apache struts library. So if we look at this chart here, what we see is that Apache was notified in mid-February of that vulnerability, and then a few weeks later, they release a fix. And just one day after they released a fix, an exploit is made available. And shortly following that, we see attacks begin, and then there's a huge peak where all the folks out there who were running the unpatched version of struts were having their systems compromised. So the key takeaway here is that if you were able to detect that Apache had a vulnerability and you were able to pick up that fix and implement it shortly after it was made available, then you wouldn't have had this issue. You would have been totally fine. So that brings us to our first hack, and this one is going to be a directory traversal vulnerability in a popular NPM library called ST. So we're in the Node.js ecosystem, and ST, for those who don't know, is used for serving static files on a website. So going over to my demo environment, I'll give you a quick walkthrough. We see the Snyk UI, which I'll come back to, but also here in my terminal window, I've got a couple of tabs open where we have an Amazon EKS cluster running. And this is where I'm running the demo apps that I'm going to show you today. And they're running as realistically as possible, except they're not on the internet, or else you'd be able to hack them too. So I'm using Kubernetes port forwarding here to be able to access them in my browser. So for our first demo, we should have something running on localhost 88, and we do. And it's a simple to-do app. There's really nothing special here. You just add to-dos like move the car and do laundry, things that you have to do. But as a malicious person, we're going to look around in this app and try to find a way in. And we see on the bottom here, there's an about page. So if we click that, just like any other website, we see some info about the site. And we also see in the URL here, it says /public/about. So as developers, we kind of just know that public is where we have our public assets, and there's nothing really sensitive here, but we want to exploit a directory traversal. We want to get out of here and start traversing through other directories to see if we can find other files. Now to start with, we might just click this to go to the parent directory, and if we do that, the application responds just like how it should. It doesn't allow us to move up to the parent directory. But if we use a specially crafted URL like this, which uses HTML encoding, we can exploit the vulnerability in ST, and there we have it. We just moved to the parent folder of public, and now we can see all of the source code in this application. So as a hacker, we're probably going to take a look at various files in here, see how the application was built, maybe look for other dependencies that have critical vulnerabilities that we can make use of. Maybe we'll take a look at the Docker Compose file, see if we can find a password in here that we could use. We can even take a look at the source code and see if there's something here we could make use of, or just copy that and save that for later. Or if we want to, we can actually keep going through the directory structure by just copy pasting here, move all the way up to the root of this server and see the contents of some pretty sensitive files like the etc password file. So at this point, I think you've got the gist that this application is vulnerable to directory traversal, and we just exploited it, and we're able to see some pretty sensitive information on this server. So now the question is, wouldn't it be nice if this weren't here at all, and a malicious person couldn't even do something like this? And of course that would be nice, and the way that we can do that is to use Snyk to find and fix this vulnerability. So the way I like to demonstrate Snyk is really kind of from the left side of the software delivery lifecycle to the right. So starting very far to the left, I want to point out that Snyk has a command line that you can use. It's this easy. Just type snyk test to test your code for open source dependency vulnerabilities. And we're using a special command here just to prove that Snyk indeed found the directory traversal vuln that we're interested in. It's in this package, st. On top of that, Snyk is integrated with the most popular IDEs out there. In my case, I'm using IntelliJ, and it's very quick and easy to install the Snyk extension. Here it is, and you can run scans on all the different layers of your application. And if we dive in here, what we should find is that Snyk discovered the directory traversal vuln that we just exploited. And on top of that, it's highlighting the exact line of code that we need to fix and explaining what we need to do to fix it. And the reason I'm pointing this out is because it's very far left in the process. This is before a developer has even committed their code and shared it with the rest of their team. We can find security issues here at this level. Then this developer, at some point is going to share this code and push it to a code repository. And here in the Snyk UI, we actually have Snyk integrated across the software delivery cycle and also across various Amazon services for each of the different phases in this life cycle. So we can start by looking at source control. And here is our vulnerable app. If we open it up, we see that Snyk scanned the different areas of this app. It's got the first party code, the container image, and also the open source dependencies in the package.json file. So if we open this up, we should once again see that Snyk found a directory traversal vulnerability, and it did. Here it is. So looking at this vulnerability card, Snyk gives us a few key pieces of information. It's telling us how this vulnerability was introduced. It's because we're using this version of this library. It's telling us when this security issue was fixed. It was fixed in this next version of the library. And it's telling us what we need to do to fix it, which is simply to upgrade to the fixed version. On top of that, we're getting a nice description in a way that developers can really understand of what the issue is. It's saying a request like this would leak sensitive files and data from the server, and that's exactly what we just saw. We get additional learning content about this kind of vulnerability, like directory traversal and others, and that's totally free to use. Check it out. It's called Snyk Learn. And finally, we're also computing a custom priority score. So this means we're taking everything we know about the vulnerability, not just the public score, but other factors as well, like is there an exploit, how mature is that exploit, is there a fix available, and so on. And this score is there to help security teams to prioritize the most impactful issues first. So we found this vulnerability in our source control system, and now after that code is there, there's a very good chance that a CI/CD pipeline is going to run. So we do have Snyk integrated with CI/CD. In this case, we're using AWS Code Pipeline. And here in the code pipeline console, we see a simple pipeline here. We're just checking out our code, building it, and then doing a scan with Snyk open source. So this means that right after our code is built, Snyk is going to tell us if we have open source vulnerabilities that we need to look into, and we can also use this to block the build and prevent it from moving on to subsequent stages. On top of that, it's very easy to add Snyk to your AWS Code Pipeline. It's built right into the AWS console, so you can all go and find that right there. Just pull down the drop down, you'll see Snyk, and then there's a connect button, which makes it super easy to connect and get this implemented. And there's monitoring functionality. So on top of running a scan every time we push code through our pipeline, we can also monitor the results. So that means that we take the results and we ship those back here to the Snyk UI like so, and we refresh those results every time the pipeline runs, or also periodically, like on a nightly schedule, so that you can stay on top of security issues as things change, because that's the nature of security. So we successfully found this vulnerability in ST and have the tools we need to go ahead and fix that. Now I want to pose a question to everybody. Now, remember that this vulnerability is in a package that we downloaded from somewhere else, and it's directory traversal, right? So is it possible that we on our own development team could write code in a certain way that would lead to a vulnerability like directory traversal? And the answer is yes, absolutely. And Snyk can help us find and fix those kinds of issues as well. So to demonstrate that, I can open this other application here. This one's called Juice Shop. Some of you might be familiar with this one. It's another popular vulnerable app. And in this one, we can see Snyk doing a few scans, including the first-party code. So jumping in here, we see that Snyk found a number of issues in the way that our first party, the code that we write, is written. So it's finding things like NoSQL injection style of weaknesses. It's finding regular expression denial of service, and so on. Hard-coded secrets, SSRF. We've got the full list here just in this application. We also make public what the weaknesses we find are. So if we filter this list down to path traversal, we see there's a few issues here. And if we open one of them up and look at the full details, we see that Snyk did what's called a taint flow analysis. So it understands how our code flows with all the different functions and variables. And what it's telling us here is that we have this request body, which is something that the user controls. The user can control what's in this request body. We set that to a variable, and then we pass it down here, and we use it to construct a path that's later used to read something on the file system. So what Snyk is telling us here is that a malicious request could be used to exploit or make use of a path traversal style of attack here. And then further, if we take a look at the fix analysis, Snyk is giving us a nice description, once again, that's really going to teach us how to avoid writing code like this in the future. And on top of that, we're also providing examples from public commits and pull requests where other people on the internet have fixed this same issue. So we can scroll through and take a look and see what other people have done to remediate this kind of vulnerability. And in all of these cases, it's really the same kind of change, which is don't allow that user to get any of their input to that path. Use something like a date instead so that we always know what it is. So moving on, I'm going to go back to my slides, and now we're going to start to focus on a different area. So let's start with some surveys to talk about this new area. So this next hack is going to deal with a container vulnerability, and in this survey, looking at the container ecosystem, what we found is that a majority of companies out there are running containerized applications. Now that should be a surprise to no one, but also we found that the top 10 most popular Docker images have over 30 vulnerabilities in them, so that's a little surprising. And then to the right, we see that a majority of the top 1,000 Docker images have severe known vulnerabilities. So that's pretty alarming. And the takeaway here is that we're pulling containers from all over the internet with all kinds of stuff inside them. And we really need to check our containers for vulnerabilities before we decide to use them and also while we're using them. Now let's consider the infrastructure as code space. So in this survey, what we find is that there are hundreds of thousands of infrastructure as code, or IAC, files out there in public repositories and countless others in private repositories that we can't see. And according to our report, the number one concern of moving to cloud-native application development is IAC security. And over 50% of the respondents have workloads deployed using IAC. So the takeaway here is that IAC is growing in usage and adoption, so we need to make sure that the IAC we deploy is secure. So that brings us to our next hack. This one is going to be a more serious vulnerability. It's called an arbitrary code execution vulnerability. And this one is in a popular web application server that you find in the Java ecosystem. It's called Apache Tomcat. So you stick your application on Tomcat. Tomcat will run your app and give you some nice features alongside. So going back to my demo environment, once again, we have our application running on Kubernetes as realistically as possible. And this one's running on localhost 8080. So we should be able to find that here. And here's our app. Once again, it's just a to-do list app. There's really nothing special about it. I can log in and we see our to-do list items, or we can add new ones, delete the ones that are already there. There is an about page here, but that's not where the vulnerability is in this case. In this case, we're running on Apache Tomcat, and that's evident if we erase to-do list and just hit enter here at the root. Now, if you configure Tomcat a certain way, you can make this page go away, but this is just for demonstration, proving that it's on Tomcat. We see our application server homepage here. And to go ahead and exploit this vulnerability, we're going to use some tooling. And remember from that slide earlier that these kind of tools exist. So we'll see how easy they are to use and exploit an application. So to start with, we have to source a shell script, which is using Docker behind the scenes to do a little magic, but all it really did was add two commands to my shell here that I can now type. The first one is called check, which checks to see if our application is vulnerable, and indeed it is. It's saying, hey, the website that you're pointing to is vulnerable to the CVE that we're interested in, and also it was able to do something here. Now, what this exploit does and what the vulnerability entails here is the ability to inject a JSP file into the server. So for those who don't know, JSP stands for Java Server Pages. It's kind of like like an HTML page, but you can write Java code in there, so you can make it very dynamic and do some cool things. And what this vulnerability again entails is that we were able to inject one of those into this server. So to prove that, we can go here and we see, that's not bad, that's a good thing, that means it worked. So at this point, whoever is running this website might have some alarms going off, or it might be 3 in the morning and people's pagers are going off. So as a hacker, we've got a few choices. If it were me, I'd probably wait 24 hours or so just to see if this page is still here and it hasn't been turned off. And assuming it is still there, what we can then do is run another command. And bear in mind, we could put a little extra work into this exploit here and make it crawl all over the internet doing this kind of thing, looking for vulnerable servers. But once we find one that's vulnerable, we can then run this. And now we've got a little shell prompt here, which is pretty interesting. But even more interesting, what happened was we injected another JSP file with a lot more code in it. And that one looks like this. So now our hacker has successfully got in. They've got a little text box that they can type stuff in. So they're going to want to know who they are and what they can do. So they'll type things like host name. We see we're in a Docker environment on Kubernetes, and that's true. They'll start looking for passwords, looking at the environment, see if we can find something in here. We can look at all of the packages that are installed on this server and see if we can find one with, again, critical vulnerabilities that we can make use of. We can see if we have internet access. So curl amazon.com, and we do. This is a good result. That means we can access the internet and maybe pull in some other tools that help us do damage. And we want to know who we are, of course. Who am I? And we're root. So as you can see, it is game over for this server. This hacker can do anything they want to. And now, again, wouldn't it be nice if this issue weren't even here to begin with? And of course, that would be nice, and we can use Snyk to find and fix this vulnerability. So let's see how that looks. I want to start with Amazon Inspector, because this is a tool that many of you out there might already be using. Inspector is a tool that can find security issues, application security issues in your container registry, Amazon ECR, and your EC2 instances and your AMIs. And I'm sure I'm not doing it justice, but I'm pulling this up because I do want to point out that if you take a look at the vulnerabilities discovered by Inspector, you'll find, if you open up some of them, that the vulnerability source is Snyk. So what this means is if you're using Inspector, to some extent you're already using Snyk. And you can also use Snyk in conjunction with Amazon Inspector. So Snyk does integrate with Amazon ECR. Pulling that up, we see a couple of apps that we have integrated, and opening up our, or actually it's the Java app in this case that we just exploited. And what we see here is that Snyk did a container analysis, and it's actually separating the findings into two different sections here. So here where the Debian logo is, this is looking at the base image and all of the vulnerabilities that came in from that. And we're separating that from the application and where the application is deployed inside that image. So this gives us some context about where these vulnerabilities are coming from and allows us to pinpoint the issues. On top of that, we're integrated with Amazon EKS as well as AWS Lambda, and this is again good for runtime visibility. So if we pull down our deployment of this app that we were just using, we see pretty much the same, if not the same, results that we saw in the container registry scan. And if we click through, what we should find is that Snyk discovered an arbitrary code execution vulnerability in Apache Tomcat. And here it is. Once again, Snyk is giving us a nice description in a way that we can understand of what this vulnerability entails. It says it was possible to upload a JSP file to the server via a specially crafted request, and that's exactly what we just did. And just like before, Snyk is giving us information about how to fix it. That's to upgrade to this version, 8.5.23. We have additional learning content, a custom priority score. And now, how are we going to go about and fix this? Actually, before I do want to cover one more thing. Snyk is also giving us some details on how this application is running in Kubernetes and also a secure configuration score. So it's telling us, hey, you're failing the privilege test. That means your container is running in privilege mode. That's very, very bad. You're failing the run as non-root test. That means your container is running as root, which we saw earlier. So these are all issues that we need to go and address. Now, the way to do that is to go back to our projects view here, because we can't exactly open a pull request against Kubernetes. So I'm going to go ahead and go back to the code repository here where the vulnerability is. Now, remember that a container is running in Kubernetes, and that container was built using a Docker file, this one. So if we open this up, what we see is that Snyk once again is showing us that this is a vulnerable container, but even more importantly, it's giving us a recommendation for upgrading the base image. So if we pull this down, what we see is that Snyk knows that our current image is Tomcat 8521. It has a whole bunch of vulnerabilities in there, and Snyk is telling us that if we just simply do a minor upgrade to 8579, and this definitely is going to fix the arbitrary code execution vuln that we saw, because it's a newer, higher version. But if we do that, we're going to reduce our vulnerability count by an order of magnitude. So that's a good start. Or if we want to be a little bit braver, we can jump from version 8 to 10 and reduce our vulnerability count even further. Or, and I think this is the best solution, we can take a look at some of these other tags that are available. It looks like some of these are Amazon Linux based and Amazon's version of Java. So if we were to switch tags and use one of these probably slimmer images, clearly that's going to be the more secure option. So we should implement one of these, and once again, it's just a matter of clicking a button to open a pull request and get that issue fixed right away. Speaking of pull requests, I do have a sample open. This is what pretty much any Snyk pull request looks like. What we see is that Snyk gives us a nice description of what's being fixed. This is the vulnerability that we were looking at before. We get a nice commit message, and one of the reasons I wanted to point this out is because we also have checks built in. So once you integrate Snyk with your source control repository, you're going to get these checks installed automatically. So Snyk is going to scan every pull request for open source security issues, for license issues, and this is important to know if you have licenses that aren't permissive, because that's going to affect your ability to distribute your software. And we're also doing first-party code scanning in your pull requests as well. So we can go ahead and fix the arbitrary code execution vulnerability by patching our container image. And remember what I was saying before about how we were failing the secure score. We were failing the privilege container test and so on. And we should fix those as well. So if we go back to our code repository once again, we can find that Snyk scanned our infrastructure as code, and here it is. And if we open that up, we see that Snyk discovered a few issues, in this case in our Kubernetes manifests. First one is that our container is running in privileged mode, just like we saw. So Snyk is saying the issue is it's privileged. The impact is a compromised container could potentially modify the underlying host's kernel. That's very bad. That means that someone can actually break out of that container and access the node that it's running on. And fortunately, we can resolve this by simply turning that off. It's pretty easy to fix. Snyk is also finding other issues in our infrastructure, like the container is running without root user control. That's how we were root earlier. The container does not drop all default capabilities, and we definitely should have, and a few lower priority issues as well. On top of this, I think it's also worth pointing out that Snyk is once again in our IDE showing us the same issues. So if we find that same file and open it up in our IDE, we go again to the exact line of code that needs to be fixed, and we get an identical description here compared to what's in the user interface. Last thing with Snyk infrastructure as code is that if you have any kind of special way that you deploy infrastructure, you can actually write custom rules and use those with the Snyk command line. And that's great because that means you can have custom rules evaluated inside of your CI/CD pipeline, and again, use those to implement security gates to prevent vulnerable code from being deployed. So going back to my slides, I do want to go ahead and wrap it up. So as a quick recap, remember that Snyk scans your first-party code, your open source dependencies, your container images, and your infrastructure as code. It's integrated in the areas that developers are working, like their IDE, their pull requests, their source code repository, their CI/CD pipeline, all the way up to the runtime environment. And Snyk is also deeply integrated with AWS. So to name a few, we have the first-party integration into AWS Code Pipeline. We integrate with Amazon ECR, your container registry, with Amazon EKS, your runtime platform. And we're also in Amazon Inspector, where the Snyk vulnerability database is the source of truth, or one of them. We are also on the AWS Marketplace, so go ahead and check us out. We have a free listing there. It does come with a limited number of scans, but I have to say it's really generous. It's enough for a small shop to be pretty effective with Snyk, so go ahead and try that out. And also, if you have an EDP commitment with Amazon, you can burn down your EDP spend by purchasing Snyk through AWS Marketplace. Lastly, we have quick starts available, and these are important because they accelerate the time to verse value for our customers, making it easy for them to deploy and use Snyk. The first one is Snyk Security, and this is what allows Snyk to do security scans for your container registry, ECR, and your AWS Lambda functions, your serverless functions. You can deploy both of those individually from this template, or both of them combined. So it's got some flexibility there. And then the last two are essentially the same thing. Both of them deploy an EKS cluster with Snyk built in, or you can use them to install Snyk into an existing EKS cluster. But the second one is totally different from the first because it's using Amazon CDK, which is pretty cool. It lets you deploy Amazon infrastructure in a programming language of your choice. So check these out if you want to try our Kubernetes integration. So that's all I have for you today. Thanks so much for attending and listening. I hope this was helpful for you and that you learned something. And if you have any additional questions after this webinar, please feel free to email me. My email's right there at the bottom of the screen. And with that, let's see if we have any questions that we can try to answer.
All right, David, thank you so much for that demo and that presentation. Marco, let's go ahead and start tackling some of these questions. So I see that you did address a couple that were sent in through the chat, but let's go ahead and just bring them up onto the screen with us.
Okay.
So to what extent will Snyk help in threat modeling and application?
Yeah, so the way I answered the question, so my name is Marco Morales. I'm a partner solutions architect at Snyk. Happy to be here. In my experience, threat modeling is part of a process, and there's different teams involved. Frequently, I've seen security teams use the process to help drive some type of change. They want to get some behaviors out of folks. And Snyk can certainly contribute to the data and information that feeds that modeling process. What we would also offer as well is think about how Snyk is designed, in the more ideal situations. If a developer has Snyk at their desktop before they even commit code, this is before it even gets looped into some kind of threat modeling process, the developer is able to address, identify, figure out security ahead of time. So we would say, definitely employ the processes that are important for your company, but also know that when done right, developers won't even be committing some of the changes that may include security vulnerabilities in the first place. So we recommend both. Thank you for that question.
All right, and thank you for that answer. So Marco, when a vulnerability is found in a lower layer of the container, but is patched at a higher layer, does that vulnerability still exist?
Yeah, so that's a great question, and there's like a little bit of a trickiness to that, right? So for those of you who are used to containers, you know that there's a layer model. I start with the base image, and I start adding new commands and new things to improve it. It is true that if I start with the base image that has a vulnerability, it is possible then that a higher level layer fixes it. So one example might be that I do a patch, an apt update or something. So Snyk will identify. Let's see if I say this right. Snyk will identify that the one of the layers has the vulnerabilities, but the higher ones may actually be fixing it up. There's more details like where we are now able to look at some of the applications running in that container. So we would invite you to let's continue this conversation and know that it's an interesting problem. And we do work within that to a certain extent. I know it's a little bit of an evasive answer, but it is part of the answer. Thank you. Thank you, Cody.
Mm-hmm. So we've got a couple more that keep rolling in. Is Snyk able to block insecure containers coming into the cluster, i.e. with an admission controller mechanism?
So I don't, out of the box, I think the answer is probably not. Like, so we're not part of a process that blocks your deployment. If your deployment uses the output from Snyk to be a gating function. So one example might be in your CI/CD pipeline, you run a Snyk scan of your containers, and if the threshold does not meet your requirement, there's too many vulnerabilities, you can block that deployment. But on your cluster side, say it's a Kubernetes cluster, we're not actively stopping the cluster from doing this. I'd like to think the question was probably meaning, can I include Snyk in a CI/CD pipeline? And so the answer for that part is yes.
Perfect. So this person has two questions. Is Snyk available as Helm or simple YAMLs?
So how I'll interpret this question is, can I deploy Snyk to a Kubernetes cluster with a Helm chart or something like that? So the answer for the Helm chart, I believe, is yes. So we have so Snyk has a whole bunch of there's a potential for me to actually over explain this. So if we want to use Snyk Monitor, which is something you install in your cluster to help monitor your running containers, as David's shown, the answer is we do have a Helm chart to help you with it. We also happen to have on the Amazon like a quick start to make it a little easier. There's different ways of us helping you deploy that monitor. If you're looking to run Snyk in a CI/CD environment, and sometimes people will say, can I use some type of automation like a Helm chart or something to run the instance? We would say that you actually have the ability to run Snyk in a container with some simple commands. And so this is really popular for our folks who use ephemeral agents or ephemeral instances in pipelines. So the whole synopsis is this segment of your pipeline is defined by YAML. We'll bring in the container, we'll run your command, we'll destroy your container, and you get your results. So that's another model if your team is motivated. I hope that answers the question. If not, please repose the question.
Yes, of course. And this participant did have a follow-up question.
Okay.
And it said, does Snyk offer RASP, runtime application self-protection?
Yeah. So RASP. So the answer is no. So we out of the box, we are. I don't want to call it a scan first company. You will notice that when we talk about Snyk, open source, and code, and the other ones, there's this element of Snyk scanning your infrastructure, your code, your repository, and so on. I'm familiar with RASP technology myself directly. And so the distinction I'd make is we do not deploy an agent into your runtime environment. And there's a bunch of questions. It's, some teams are really comfortable with saying, I'm okay with a third party running in my production environment. Some teams will say, I do not want any extra overhead, memory, CPU, etc. in my production environments. That is a discussion that's best handled by you and your team. Snyk does not provide an agent to do the runtime applications self or whatever it's called. RASP stands for. Don't quiz me on that at this moment. We don't provide that agent, so we don't do the active blocking that you would expect from a RASP solution.
So can we detect reverse proxy attacks using Snyk?
So that to me, so I think the answer. So I have some background, for a few years, maybe even several years with security. A reverse proxy attack I don't think I have the answer for that. To me, I'm the thing I have to go to my notes or find out is that meant to be like a dynamic or a runtime security, or is that something that we do statically? To me, it feels like the wording makes me think it's maybe dynamic. If there can be a clarification during this session, please do help me understand that.
Of course. So this question reads, what programming languages does Snyk code currently support?
Yeah. So offhand, I don't have the list memorized, right? But I know it includes Java and the popular, JavaScript and other ones. I encourage you to navigate to Snyk's website and see what languages are supported for the different products. Snyk code, as I do this, I'll actually start typing it on the window over here and give you an answer in a second. But we do have it published publicly, so you can see for that. So I'm looking at Snyk language support. How's this? I'll go ahead and do this. So if you do a Snyk language support search, I use Google, you'll find the different languages and frameworks. And right here, just as I read and talk at the same time, C#, Go, Java, JavaScript, PHP, Python, Ruby, TypeScript, and Apex are the languages. There are more frameworks, but that will be a different part. And they have, so I know the frameworks are important for those people who use like Node platforms. There's a whole list of them there. Again, I encourage you to search, navigate straight to our site and see if your favorite language is covered on there.
Awesome. Yeah, thank you for that full and in-depth answer. So our next question reads, Marco, how do base image upgrade recommendations work if I use custom base images?
Yeah, so we have a two-part answer. So you know that in the demonstration, David mentioned we don't have visibility. There is a distinction that we can make. So back maybe even as early as 6 months ago, we did not have this concise answer. We now do. We actually now work within your local environments, understand your local base images, and we have an answer. So if you are comfortable with us scanning and working with your local images, we do have custom, I think we call it like custom image base, or a custom base image support is something we support.
All right, so Marco, I've got a question for you.
Yeah.
Did you learn anything from this demo today?
Yeah, so so I did. So if I like watching other people do demonstrations. I have my own style. If you've seen any of those, I think what I like is it's really useful for people to sometimes see the live demonstrations. The sequence is actually something I'm familiar with, but it's the narrative that's important. So I believe when David emphasized, some of the consequences of an attacker has this, they may want to do an extra thing or two. That color commentary is super important for you to know, because the attacker has all kinds of motivations. They have all kinds of techniques. And once they get their beachhead, which is a phrase I've seen people use, they'll do any number of things. And it's really important to know that's almost their job. That is their job, to attack us, and be aware of how many different ways they can do that. So definitely keep that in mind and stay safe and secure. Thank you, Cody.
Awesome. Awesome. No, thank you so much, Marco. I'm not seeing any more questions at this moment, so I'm going to stall for time and give away a couple of gift cards. So the 4 winners of our $25 Amazon gift card drawing, they are Randy F, Stellus P, Victoria P, and Jen A. So to our 4 winners, congratulations. Keep an eye on your inbox, as you should be receiving your gift card in about the next 48 hours. If you don't happen to see that email, check your spam folder just in case it gets filtered. And I am seeing a question about this presentation being shared afterwards. So I will remind everyone, this session was recorded. You'll receive an email with a link to access this recording on demand, or of course, you can find it living on the Container Journal website at containerjournal.com/webinars. And it should be there end of day by tomorrow for sure. All right, Marco, this is looks like a bigger question, but what kinds of container vulnerabilities can be detected?
So if I am right, so we do have like the base image recommendations, and the short story there is like we have a pretty good set of partnerships with externals. We have a very large list of all the base images, and we know the different hierarchy. Version 1 goes to version 2 and so on. So we definitely provide those kinds of informations. We also have operating system support. So the operating system may include some packages. We do those scans and let you know that your operating system, your package may be out of date. and you want to do more. There is one more. I have to think about it where we normally talk about that. I may have to get back to you on that one. And I think it has to do with libraries. That's my answer.
All right. Well, Marco, it looks like we have exhausted all of our questions. So was there anything that you felt our audience needed to take away from today, or anything that really stood out to you?
So David made the comment that the solutions available, he used the word free in more than one way. We do encourage people, just try it out, right? The product is available. You can use it in your favorite IDE. You can run a certain number of scans a month for free. It's easy to get your hands dirty. As a person that's skilled with the Snyk tool chain, I can get it installed and up and running in my computer, a brand new computer, maybe 5-10 minutes, right? It does not take a long time. The extensions, I use Visual Studio Code. It's just what I run with. You may use IntelliJ or Eclipse or something else. Those are pretty quick. It's easy to get started and look at it, and then start seeing results. The scans for our public-facing Git repo has a number, dozens of different vulnerable apps. I recommend you don't run this in your production environment, but definitely have a look. It's free for you to browse. It's free for you to run it in your own test container. It's free for you to just run a scan and observe their results. What I see is people will get used to it pretty quickly and see the different levels. All the questions that are asked here are either directly or indirectly sometimes answered just by looking at the output, either on the UI, the IDE, or the web page, or your CLI.
Awesome. Marco, it looks like we keep getting questions. So let's go ahead and just tackle one more.
Okay.
There is a push to provide Sbombs for systems. How do you see that approach fitting together with scan-first approaches?
Yeah, so Snyk has active opportunities and developments and public assets and narratives on this. So we are supporting SBOM. We know that it's in the United States, there's a federal mandate. We are plumbing in, I forget the Cyclone DX and SPIDX or something. Someone correct me where I'm wrong. We are supporting those. It does feel like one may be winning out over the other, but we value that. Some of the problems that we're trying to solve is like, what does it mean to have a manifest? The question is easy to ask. Give me an SBOM. All right, what do you want in it? And so we have a lot of the support, like maybe even from day one from our API. If you were to do a query for all of your open source libraries and its transitive dependencies, you were able to get that, JSON files included. We're looking to make that more formal, more deterministic, because while the information has always been there, it's the use cases. How do you want to see it? Do you want to see it in a PDF? Do you want to see it in a spreadsheet? There's like a lot of 1,001 ways for people to ask that question, and we just have to figure out, what's the best way for all of us to work on this together.
Yeah, I think that's a big question going into the next year and the years following. So, well, Marco, thank you so much for your time today. I really appreciate you really thoroughly going through all of our questions and sticking around with us today. So thank you so much.
Thank you.
I'd like to thank our audience for being here today. I'd like to thank AWS and Snyk for sponsoring our program. And to everyone who has joined today, we appreciate you being here. We really appreciate the time that you take out of your schedule to join us at Techstrong Learning. And if you could just stick around for one extra moment for a survey that will pop up on your screen as soon as we close out. We'd really like to hear your thoughts on today's program, or perhaps what you'd like to see on an upcoming program. Otherwise, we do hope to see everyone at a future Techstrong Learning experience. Have a great rest of your day, and you may now disconnect. Marco, thank you once again.
Thank you.